Simplifying by factoring, this is a major topic. Okay. First of all, before I even rearrange or simplify a little bit the numerator, I'm going to ask you how many terms do we see at the top?
2.
Excellent. Thank you. There are 2 terms. This is the first, and this is the second. Absolutely. The first term has 3 factors. Well, more than 3 if we consider the power, but 3 different factors. The second one has 3 different factors. And I will rearrange the first one because I don't like this factor of 6 right there in between, squeezed between those two. So I'm going to rearrange it as write 6, x minus 1 cubed, x plus 2 to the third, minus 3, x minus 1 squared, and x plus 2 to the fourth. And then I'm going to ask you, please identify the common factors at the top. I don't need the powers just yet. Just identify the different the common factors in both.
3,
Yes?
x minus 1, and x plus 2.
Excellent. Let's discuss exponents now. X minus 1. Which power will the factor outside have? I see power 3 in the first one. I see power 2 in the second one. What power will come out?
2.
Exactly. From 3 and 2, the only two common factors are the same. The first one has 3, but the second one has 2, so the common is just 2. Two different factors, two factors the same. Power 4, x plus 2. The first one has power 3, the other one has power 4. Which one will I choose? Very good. And now please carefully tell me what is left inside brackets from the first term before we get to the negative sign, before we get to this sign. What is left from the first term? The 3 is out, x minus 1 squared is out, and x plus 2 cubed is out. 2 times. Excellent, very good. Now what is left from the other term? 3 is out, x minus 1 squared is out, and x plus 2 cubed is out. Right. So please put it in parentheses or directly distribute the negative sign. Because if you don't, then you may forget. Okay, perfect. So at this point, only at this point, I can do this. Take away 2 factors of x minus 1 from the top and respectively 2 factors of x minus 1 from the denominator. So then the final simplified form will be 3 x plus 2 cubed. In brackets, I have to remove everything. So I have 2x minus 2 minus x minus 2 over x minus 1 squared. So this will be 3x plus 2 cubed over x minus times x minus 4 over x minus 1 squared. This is extremely important when we get to chapter 4. When we calculate derivatives and find critical numbers, points of inflection, etc. Okay. Any questions? Is this okay, everyone? Okay, the next one is a polynomial function, p of x, negative x cubed minus 9x squared. Now, the end behavior of this function will be kind of redundant because we're going to apply limits to it, but we'll talk about it. The zeros and the multiplicities are important. That's fine. This is all pre-calculus material. Okay, in first question, we have find the y-intercept. So how do I find the y-intercept of this function? Right, so p of 0 is 0. So the y-intercept is 0, 0 if you are asked to put it in an ordered pair format. Were you able to register in WebAssign already? Yes? Okay. Let me know if there is any question coming from WebAssign at any point in time. Okay, so then we're asked to describe the end behavior. So what type of function is this? Yes, it's a cubic, in general, a polynomial function. What is its degree? Its degree is 3. The highest power of x, right? Degree is 3. We're not adding exponents. So the highest power is the degree, so it's 3. For any odd degree, 1, 3, 5, 7, any polynomial function has 2 options. One option, second option. What does the first option mean? Positive leading coefficient. Coming from negative going to, right. A negative leading coefficient, which means negative slope if you want. This is not a slope, but you know what I mean. Coming from positive going to negative. What if the degree is even? What are the options for even?
Both up or both down?
Positive leading coefficient, negative leading coefficient. Since it's cubic, degree 3, and the leading coefficient is negative. What is the end behavior? End behavior from positive to negative. So it's going to be something like this. From positive infinity to negative infinity. This is the end behavior. It cannot turn more than twice. Okay, then they ask us to determine the zeros. How do I find the zeros of any function? I set it equal to 0. That's the zeros. The zeros or x-intercepts mean the same thing. So p of x equals 0. So negative x cubed minus 9x squared equals 0. Again, what is the degree? How many solutions?
3.
Exactly. Excellent. If the degree is 3, we have to find 3 x-intercepts. They may all be the same. 3 x-intercepts. 3. Okay. First of all, I refuse to solve any equation with a negative leading coefficient, so I'll multiply by negative 1. So then I have x cubed plus 9x squared equals 0. What will be the next step? Obviously, I have to
I would factor.
absolutely. What do we factor out? Anyone?
Oh, x squared.
Excellent. And you're going to give me 3 solutions. Perfect. Can anyone give us 3 solutions?
-9.
Good. Perfect. -9, 0, and?
Just 0.
Exactly. 2 solutions are 0. 1 solution, x equals -9. This has multiplicity 2, and this has multiplicity 1. What does multiplicity 1 mean? What does multiplicity 2 mean? What does the function do there?
Nope.
0 there twice, and then multiplicity 2.
Correct.
I remember seeing that in the video. I wasn't sure what it meant or how you
Okay.
clarify that it would be 2.
Very good. This is from pre-calc. So let's take a look.
Oh, was it that touching?
Okay. I think we agree that here the function crosses the x-axis. Agree that here crosses the x-axis. And agree that here it crosses the x-axis. Here it crosses the x-axis with no delay. Here it takes its time. Here it takes even more time. It doesn't mean that it has 3 intercepts or 5 or 7. But it gets closer and closer, it's not touching yet, it's not crossing yet, closer and closer, not crossing yet, closer and closer, not close. Okay, finally crosses, and then slowly, slowly moves away from it, from the x-axis. All these are odd multiplicities. It means that the x-intercept exists once. It means that the x-intercept exists 3 times. And here even slower, what do you think?
5.
So when we determine the multiplicities, this solution will appear once. That's why multiplicity 1. This solution will appear 3 times. That's why multiplicity 3. And this solution here, although it's just 1, all of them are just 1. But it appears 5 times. So every time a function crosses the x-axis, it may cross in different ways. Fast, slow, slower, slower, depending on multiplicity of that particular solution. What do you think will happen in these situations? Where it touches. It's tangent, if you want. But it does not cross. What type of multiplicity would that be? Just think of x squared, and you know what happens. Yes, even multiplicity. So this is 2, this is 4, this is 6. So but even multiplicity, like in this case, the function will not cross at 0, but it will cross at -9. At 0, we'll have a term. It will be this kind of term, either from above or from below, but it will have a term. A short term or a fast term, not a slow term, not a slower term. It will be a fast term because multiplicity is 2. Is that better? Yes? Okay, moving on. 15, any questions? So we determined the zeros and their multiplicities. So we can write here, this is a turn, 0, 0 will be a turn, and this will be a regular cross. -9, 0 will be a regular cross of the x-axis, not a slow cross. Okay, the next one, odd or even. Again, we need this in this course to be able to identify which function is odd and which function is even. So, bless you. For a function to be odd, if you don't remember, I'll show f of -x equals what?
-x.
Thank you very much. And for an even function, f of -x equals, that's it. So in our problem, we have f of x equals -x cubed minus 9x squared. Every time we try to determine whether a function is odd or even, we always determine this. This is our starting point. We determine f of negative x. If it happens to be the opposite of f of x, then it's odd. If it happens to be identical with f of x, then it will be even. If none of the above, then the function is not symmetric. There are no functions that are odd and even at the same time except y equals x. But who cares about y equals 0? Who cares about y equals 0? This is the only one that is symmetric with respect to the origin and with respect to the y-axis. F of x equals 0. Okay, so I plug in negative x based on what we just discussed today. Negative x to the third power is still negative x to the third power, and with minus in front would be positive x to the third power. This does not change, so it's negative 9x squared. So I ask myself now 3 questions. Does this equal the identical function? Does this equal the opposite of the function, or none of the above? And there is only one answer yes here. It's either f of x or negative f of x or none of the above. Does it equal f of x? Compare these two and say, does it equal f of x? No. So then the function is not symmetric with respect to the y-axis. So even means symmetric with respect to the y-axis. I should have written that before. And here is with respect to the origin. From the trig functions, do we remember which ones are odd and which ones are even? Only cosine is even, and therefore the other function that has only cosine in it, which is secant. Everything else is odd. So cosine and secant are the only functions that are even. All the other functions have sine in them, and sine is odd. Therefore, all the other 4 must be odd. Only cosine is even, and the only function that has just cosine in it. Everything else is odd. Okay, so we established that the function is not even, not symmetric with respect to the y-axis. But now I will compare. I did not calculate negative f of x, so I'm going to put negative on both sides here and determine negative f of x as being x to the third plus 9x squared. So now I'm comparing these two. If they are the same, then I'll say the function is odd. If these two are not the same, then I'll say not symmetric. Are these two the same? F of negative x, is it the same with negative f of x? No. So this function happens not to be symmetric. The next one is a rational function. I'm sorry, rational equation. So do we need to do that one? Yes or no?
Yes.
Perfect. So we have x plus 2. Any question? No, it's not x plus 2. It's x plus 5, sorry. Over x plus 2. Any questions on the previous? Yes, it is. I'm going to change it. Thank you so much. Any questions on the previous problem with odd-even functions? Where do we need this in this course, the odd or even? When we graph functions. That's one example. Good. So this is a rational equation. I will show you the method that I like to present, and if it makes sense, use it. If it doesn't, please use the method you've been taught before. You got to this class. So what I'd like to do is I like to move these two terms to the other side. If I move these terms, if I move terms from one side to the other, I only change the sign in front. But if I move these two terms here, I'd like to know what is left on the other side. Very good. So when we move what is on the right-hand side to the left-hand side, I still have to write something, and that is 0. There's nothing else left. So why am I doing this? Just to emphasize, each equation has the left-hand side, has the equal symbol, and the right-hand side. If you omit any of these 3 pieces, or you continue simplifying to the sides, I will not look at the problem. Each equation has to be written one below the other. If you go to the side, that's fine, but you cannot write equal symbol. So there are blocks of 3 units. Left-hand side, equal symbol, right-hand side. Left-hand side, equal symbol, right-hand side, or one below the other. I can't see anything to the sides. Here's why. You can say, oh, she wants her way. No, I'll tell you why. If you continue simplifying to the sides, at some point in time, you'll forget you're solving an equation. You'll forget which one is the left-hand side and which one is the right-hand side, and you're not going to solve. It's not that I want it my way. Okay, so please remember that. So the left-hand side is now x plus 5 over x minus 2 minus 5 over x plus 2 minus 28, and I will definitely factor the denominator into x plus 2x minus 2. And then I continue. Where's my exit? Okay. So a term, it can be a fraction, it can be anything. With a positive sign in front, when it gets moved to the other side, it becomes negative. A term with positive in front, the same thing, moves to the other side with negative sign. Also notice that all these should be on the same line. The fraction line, the negative symbol, the fraction line, the negative symbol, the equal symbol, and 0. They should all be on the same line. Okay. So now I will have to state restrictions. Restrictions on x. How come? Why do I have to use restrictions on x? And what is that? Excellent, thank you very much. So the first one has a restriction that x cannot be. Excellent. The second one has a restriction that x cannot be. And the same two are in the third one. Don't need to repeat those. And now I will write a fraction line, the equal symbol. Again, if you forget the equal symbol and 0, you are changing the equation into an expression and you're not going to solve it. Does it make sense? Perfect. Now I need the LCD. Can anyone give us the LCD, the least common denominator of this?
X plus 2 times x plus 2.
Excellent. So now I need adjustments. The numerator of the first fraction has to be multiplied by exactly the same quantity that the denominator was multiplied to get this. What did I multiply this denominator by to get this?
X plus 2.
I have to do the same thing to the top. So I have to, this is a note to myself. It's not a fraction line. It's just a reminder. Hey, don't forget, you multiply the denominator by x plus 2, you have to multiply the numerator by x plus 2. The same thing, I multiply the denominator of this by, so I have to have an x minus 2. Here you don't have to write anything, or you just write 1 if you'd like, because we have the same denominator that we had before. Now you can ask, and I'm going to write it, but I'm going to cross it out. I'm not going to use it. You can say, why don't you write this? X plus 2 times x plus 5 minus 5 times x minus 2 minus 28. Here's why you can. You can. I support that. I agree with it. I will not write it. I will erase it. Why? Because some of my students do this. And that's a terrible mistake. So therefore, I multiply, and I write the already multiplied form to avoid that possibility, that risk. So x times x, x squared, x times 5, 5x, 2 times x, 2x, and plus 10. You have to do this anyway. If you write an intermediate step or you don't write the intermediate step, you still have to write this step. So I'm trying to avoid that possibility. So negative 5 gets distributed to x to get negative 5x, and negative 5 gets distributed to negative 2 to get positive 10, and then a negative 28. The next step would be to combine like terms at the top. Let's see, yes, these two go away. And then I have x squared. I do have plus 2x. Negative 28 plus 20 will be negative 8. divided by x plus 2, x minus 2 equals 0 or 0 over 1. Option 1, and then option 2. If you have option 3, I accept option 3, and so on and so forth. I'd like to present two options. One elegant option is this. A fraction is 0 when the numerator is 0. If the denominator is 0, we are in trouble. So a fraction is 0 only when the top is 0. That's option 1. Option 2 is to identify that this is a proportion. This times this must equal this times this. Then you write the same thing. You still write that the top is 0. So this right now here is a proportion. And only in a proportion, what is a proportion? A fraction on the left, the equal symbol, and a fraction on the right. This is it. If I add a plus 1 or plus 5 in here, it's no longer a proportion, I cannot cross multiply. So only in a proportion I can write this. A times D equals B times C. Same thing here. So option 1 was a fraction is 0 when the numerator is 0. Or it's a proportion 0 over 1. This equals this. Same thing anyway. I want you to refresh your memory on. So a proportion is still a rational equation. However, is a simpler rational equation than the one we started with. How come I can't do this here? Because this is not a proportion. I can cross and multiply. This is not a proportion yet. We changed it into a proportion. If you know an option 3, if you have a different way of doing or solving such an equation, I accept it gladly. So obviously we will factor this. What do we get when we factor? So x plus 4, x minus 2, and we get two options as -4 and positive 2. My first thought is right here, immediately. That's why I wrote those restrictions. So what do I conclude? X equals only -4. Positive 2 is not accepted. It will create two fractions out of 3 to be, or turn them into undefined. Okay, questions? Yes, please.
So when I did it, I factored out the x plus 4, x minus 2 before I got rid of the denominator
Okay.
and just crossed out the x minus 2. Is
You
there a
can.
time that you wouldn't be able to do that?
You can. No, I don't think so. But if you don't write the restrictions, I can give full credit anyway. And the restrictions have to be written on the raw function, raw equation. So yes, I accept that method. But it's not the best because you may omit to write restrictions and that will be a problem. So be careful with that. Perfect. Excellent. Other questions, please? Yes, please.
I might miss the difference between option 1 and option 2. What's going on?
As the result.
No, just the result. Okay.
You can say, okay, I got into a proportion, now I can cross multiply writing 0 over 1. Or you can think in terms of, okay, it's a fraction, it's set equal to 0, only the top can be 0, the bottom cannot. Same thing. Okay, find the exact value. Sine 11 pi over 6. We have to go to the unit circle. Can anyone tell us what is pi over 6 in degrees? We're not going to use degrees in this class, but when we apply sine to it, it doesn't matter.
30 degrees.
Yes, 30 degrees times 11 is 330 degrees. So that is 30 degrees shy. So it's this angle. So this is 11 pi over 6. What is the reference angle then?
5 or 6.
5 or 6, right? Which is 30 degrees. Good. So what is the value of sine? What is the sign? Not the value, sorry. What is the sign of sine in the fourth quadrant? Now, let's analyze where we measure sine. On the y-axis. So what is the value of sine? What is the sign of sine in the fourth quadrant as well as the third? Negative. So that would be negative. Sine of the reference angle. So now we think in terms of sine of 5 or 6, which is the smallest angle. Okay, let me give you a little, say it again.
1/2.
Yes, indeed. Thank you very much. So this will be then negative 1/2. So all of you have to remember is this. Sine, cosine. And this is pi over 6, pi over 4, and pi over 3. So let's do this together so you can understand how easy it is to remember these three numbers. Ready? So always remember the sine of the smallest angle is 1/2, and so is cosine of the largest angle of the three. This is the friendliest because the numbers are the same. Just put up 2 over 2, and then you reverse these two. Where do we measure cosine? Very good. So cosine is measured here, and sine is measured here. Sine is the height, the opposite, and cosine is the adjacent. So that's why we measure it horizontally, and sine we measure it vertically. So now the question is, where is cosine negative 1? So if cosine is measured on the x-axis, it must be 1 here, and it must be negative 1 here. So the answer would be,
Pi over 2.
careful,
2 pi.
Oh, just pi.
pi. So this is 0. This is pi over 2, this is pi, and this is 3 pi over 2, and this is also 2 pi. Any questions? Okay, ready? I didn't expect to use 4 hours on this. Well, actually 3. But moving forward, I'm hoping that you're going to review this. Okay, so we have a trig equation, and they want us to find only solutions in one full circle. They don't want us to determine all possible solutions. There are infinitely many. Okay, so does anyone remember that this is an identity, sine 2x? So does anyone remember what sine 2x equals to? Okay, 2 sine x cosine x, and I will move sine x to the other side. What is left on the right-hand side when I move sine from right to left?
0.
Of course. Let's look at this equation. So sine twice x, sine twice the angle is 2 sine x cosine x. Okay, so look carefully to the left-hand side and say, I know you're going to do this now, and I'll do it.
Pull a sine.
Absolutely. I want to work with factors, not with terms. Excellent. Thank you. 2 cosine x minus 1 equals 0. So there are two possibilities here. Sine x to b and cosine x to b. What are the options? What are the options? Obviously, sine can be 0, right? And cosine can be 1/2, right? 2 cosine x minus 1 means cosine equals 1/2. We agree? Please say no if you don't, and I'll show. Do we see it?
No.
Okay, so this is a product. We are using the zero product principle. If A times B is 0, then A can be 0 or B can be 0.
Oh,
If A is 0, I get sine x is 0. If B is 0, I get 2 cosine x minus 1 equals 0. I move 1, divide by 2, and get cosine equals 1/2. Agreed?
Yeah.
Perfect. So that's okay. So now, where is sine 0? We measure it on the y-axis. So sine is 0 for and.
3 pi.
Very good. So sine x equals 0 has two options, x equals pi over 2 and x equals 3 pi over 2. They don't want us to determine anything else beyond that. And now we have to solve the equation cosine x equals 1/2. And first I'm going to ask you, where is cosine positive?
first quadrant and fourth quadrant.
First and fourth, very good, excellent. So then we have to come up with two solutions. So let's do that. What are the two solutions?
Pi over 3.
Indeed, x equals pi over 3, so this is exactly here. And at the same cosine value, this is the piece, that is 1/2. At the same cosine, I have to have the other angle, that is this. Having the exact same cosine. So this and this are the same, are angles with the same cosine. So the reference angle has to be the same. If this is pi over 3, this must be pi over 3. So please subtract from 2 pi over 3 to get the other angle. 2 pi minus pi over 3, which is 5 pi over 3. Agreed? Very good. Okay, what else is here? I know we have 5 minutes. Let's try and finish this. So I know we have to sketch this graph, and let's do this first, and then we'll sketch the graph. So normally when we apply arcsine to sine or sine to arcsine, we're tempted to write 3 pi over 2, right? Because arcsine should eliminate function sine, and sine should eliminate function arcsine. However, this will be incorrect. For this particular case, we cannot apply the property of inverse functions. Because when we talk about arcsine, the answer has to be between negative pi over 2 and pi over 2. And the answer is 3 pi over 2. So that is the domain, the truncated domain of the function sine, so that we can use the inverse function. So therefore, in this case, we cannot write blindly 3 pi over 2. We cannot use the property of inverse functions. We have to determine this number. Can anyone, not that, you know what I mean, the sign of that number, sorry. So what is sine of 3 pi over 2? Sine of 3 pi over 2 is negative 1. So then arc sine of negative 1 will be, which angle has sine -1. But the answer has to be between -π/2 and π/2. That's it. So this would have been correct. Arc sine of -π/2, this would have been -π/2. In this case, I can use this as sine. I'm rushing now because I want to finish the last problem. So in this case, I would have been able to apply the property of inverse function, but I was not able in the first one. Okay, so let's see what we can do here. Very simple situation, because when we graph sine, we know that sine is the base function, right? Sine x, here's the graph of sine x. Pi/2, pi, 3π/2, and 2π. And this is 1, and this is -1. We say that sine is a bounded function. Sine x is bounded between -1 and 1, and so is cosine. So this will be the graph of sine. It's not a perfect graph, of course. Sorry about that. But now I have a function that is sine x minus π/2. What will happen? And we discussed this several times today with other functions, not with this one. So what transformation will this be on this graph? Where does it go? To the right, how much? π/2. So then the graph will start here. We'll still go to 1. So this will be the graph of sine x minus π/2. And my graph, which I think looks better, it will be this. So this graph is sine x minus π/2.